Hi guys, I'm going to work through a few of these examples on the round 2 of review of inverse trig functions to help you out. Okay, so when you see a composition of trig functions here, work on the innermost part first. We want to find, knowing our unit circle, sine of 5 pi over 6, which has a value of 1/2. Okay. So now I want to find sine inverse of 1/2. And remember what that means. And if you need to watch the video again from yesterday, I went over the single steps of these inverse functions. This means sine of what angle equals 1/2. And remember, they only have one answer depending on its restricted domain. So sine inverse of 1/2 is going to be pi over 6. And again, our domain restrictions on sine are restricted to the first and fourth quadrants. That has to be between negative pi over 2 and pi over 2. Okay. Now on number 4, we're doing an inverse first. Okay. So I want to find the angle, sine of what angle equals negative root 2 over 2. So again, if you want to think of it like sine of what angle equals negative root 2 over 2. Again, sine inverse is restricted to first and fourth, and if this ratio is negative, we're going to be down in the fourth quadrant. Between negative pi over 2 and pi over 2, that means it's going to be negative pi over 4. It's right there. Okay. So now, once we find that value, we want to find tangent of negative pi over 4. Well, negative pi over 4 again is going backwards, so it's down in the fourth quadrant. And what is the tangent value there? Well, both sine and cosine are the same but opposite signs. It's root 2 over 2, positive and negative. So tangent, of course, is going to be negative 1 in the fourth quadrant. So those are a little more involved than the ones yesterday, but just again, take it step by step. It's basically 2 problems. Find the innermost part first, and then again, whenever you're finding a sine inverse, that's finding the angle going backwards. Okay. Now, these are the types of problems a lot of you were confused on the test this last week, is these are not special angles. So we want to find the answer by sketching an appropriate triangle. So when we look at cosine inverse of 3/5, okay, again, an inverse represents an angle. So some teachers make their students write, okay, you're finding sine of theta, right, where this is equal to theta. Okay, essentially, theta is equal to cosine inverse of 3/5. So you need to draw a triangle where the cosine ratio is 3/5. So make sure you label your angle so you know what you're looking at. So adjacent over hypotenuse should be 3/5. And I want to find sine of that angle. So sine of this angle would be opposite over hypotenuse. So of course we use Pythagorean theorem or know that that should be 4 in this case. Sometimes you have to do math. That one we don't have to. So sine of theta should be 4/5. Okay, so again, sine of that angle. We're drawing that relationship. Okay. So 10 looks similar. It's a little more difficult. We want to, again, draw this relationship. We want to draw this triangle. Okay. Representing an angle whose sine is 3/4. So opposite over hypotenuse. So we need to find the missing side. So doing Pythagorean theorem, you're going to do x squared plus 3 squared equals 4 squared. So 16 minus 9, x squared equals 7. So x is root 7. Okay. And then it's saying to find secant of this angle. Secant is the reciprocal of cosine. So instead of adjacent over hypotenuse, we're going to take hypotenuse over adjacent. And always remember to simplify. So our simplified answer should be 4 root 7 over 7. Okay, so I did 4 of your 12 problems. I hope that helps you get started. I saw a lot of people with questions on those types of problems, and I hope you'll have more success this go around, you guys. Good luck, and let me know if you have any questions. Thanks.